Hi, Virtual Chemistry. Today we are going to go through how to do the lab calculations on your empirical formula of copper carbonate experience. Hopefully by now you have watched the previous video that I put into Canvas under your modules. So you should watch me do the lab experiment so that you can pull the data that was included in that video. But today what we're going to go through is it's on this PDF. You're going to excuse me because I'm not so great videographer. So this PDF is available to you in Canvas. What you have to do for the lab assessment grade is you're going to do the pre-lab calculations. So I'm going to flip my paper to that. So you're going to do these pre-lab calculations here, okay? So I'm going to kind of talk you through these. You definitely want to have your periodic table and your calculators handy, all right? So you have to do the pre-lab calculations for your assessment grade. You do not have to put this into your regular lab report document. You could just, if you write neatly enough, you can put all your answers onto this piece of paper. If your handwriting is very large or very messy, then you might want to record all of this on a separate sheet of paper like it asks you to. So the first thing you're going to do for number one is you are going to formulate copper 1 chloride. You should be able to do that with the skills you learned in semester 1. So copper 1 means it has a +1 charge. Find your chloride on the periodic table. It's number 17. Find its charge. Once you know each of their charges, crisscross them if needed. If they have the same exact charge, all you have to do is squeeze their symbols together. So once you have it formulated, you're going to write the formula right there. It says write the empirical formula for the following compounds. The formula will be the empirical formula. It'll be the smallest whole number ratio of coppers to chlorines in the compound. It says, and then calculate the percent composition of copper. Well, copper is one of those elements that I need you to keep at 63.5 for its atomic mass. So once you formulate it, you will take copper's contribution, the number of copper atoms times the 63.5, and you will divide it by what the molar mass of copper 1 chloride is. Then you would multiply that by 100 to turn it into a percentage. You'll do this similar process with copper 2 chloride. This time copper's charge is 2. Chloride's charge is the same. So make copper's 2 follow the chloride. Make the chloride charge follow the copper as its subscript. And again, calculate your percentage of copper in that formula by taking your number of copper atoms times the 63.5 atomic mass and dividing it by the total mass of copper 2 chloride. Multiply it by 100, okay? The next thing you're going to do, and these formulas are written a little bit different, is you're going to calculate the molar mass, percent composition of copper, and percent of carbon dioxide from the carbonate ion in these two compounds. One of these compounds was what you were analyzing in the lab, or what I analyzed in the lab. So what I've done is, on my board here, for number 2, I kind of have to back it up here a little bit. Ignore that stuff that's written in orange. That was from today. You have the two compounds. The first thing you're going to do is calculate the molar mass in the grams. Most of this is already basically worked out for you. All you have to do is tally it. So for this first compound, I gave you the atoms of copper, the oxygens, the hydrogens, and the chlorines. Multiply them by their atomic mass to get the total contribution, and then add them all together. That is what you would put under the molar mass. You're going to do the same thing for the second compound, the Cu3OH2CO32. Remember, those 2's get distributed. 2 times 1 oxygen is 2 of them there. 2 times 3 oxygen is 6 of them there. 6 plus 3, 8 oxygens. 2 hydrogens, 2 carbons. Again, total the grand tally of atomic mass, and that's what goes right there for compound 2. The next thing it asks you to do is to formulate the percentage of carbon in each compound. So you would take the carbon's mass, for example number 2, 3 at 63.5, get that number, and divide it by the grand total of the chemical compound, then multiply it by 100 and record it there. You'll do the same thing for the first one, 2 times 63.5 divided by the grand total. Put it in your table. Lastly, number 2 asks you to come up with the carbon dioxide's composition based on the carbonate ion. So I got this blue around my carbonate ion. So sample number 1 has 1 carbonate ion, 1 CO3. So we need to look at carbon dioxide's molar mass. 1 carbon atom at 12 gives you 12 plus 2 oxygens at 1632. So 44 grams is what carbon dioxide weighs in molecule 1. So take 44, divide it by the total molar mass, which you had entered right there, times it by 100. Record that number. In the second one, look, there's 2 carbonate ions. That means you have 2 carbon dioxide ions. So what I did here was I took 44 times 2 equals 88. I'm again going to divide it by the total molar mass, which you had calculated earlier. You're going to times it by 100%, and that's going to tell you what your percentage is. Bear with me while I erase this orange stuff right here out of our way. Okay? So, there you go. You should have filled in this table for number 2. Okay? Make yourself a table that looks similar to that, please. Now we're going to go with how you're going to do the calculations for this. Okay? So, I want you to label these columns 1 through 10 going down the side. So they give you the flask's mass, then they give you the mass of the flask and the metal carbonate. So if you need to find how much metal carbonate you used, you basically take line 2 and subtract line 1. That's what you'll enter right here. And then it tells you had a cylinder with hydrochloric acid in it. After you dumped the acid into the flask, you weighed the cylinder dry. It was 11.812. So in order to find out how much your HCl added, you just take line 4 and subtract line 5. That's what goes right there. Number 7 says the mass of the flask plus the metal carbonate plus the HCl. Add lines 1 plus 3 plus 6. That's the number you report there. Next, you need to know the mass of carbon dioxide released. That would be whatever you found in line 7 and subtract line 8 from it. Finally, what's the percent carbon dioxide in the metal carbonate sample? That would be line 9 divided by line 3, which was the plain metal carbonate. Multiply that by 100%. Then you're gonna fill that out, okay? The next thing you need for the lab is, if you have watched the video, you should have gotten all these numbers from the video. If you didn't watch the video, here's your special gift. You better record those right now, because I did the math, and I did it correctly. So, there's a little gift. I've done all the calculations for you, okay? You do not need to do this part down here, the post-lab analysis. That's really all you did right there. It was the same thing that you have to do on this page. Same exact lines, same exact formula. So lastly, for your lab report, you need to fill in this portion right here. You're going to put the percent carbon dioxide theoretical for each compound. That is what you found on the board right here by doing that math. Those two numbers go here and here. The percent of carbon dioxide experimental, that is this number that Mrs. Noble calculated for you. That's the number you should write right there. Your percentage of copper theoretic, that you copied or you calculated right here on the board, those two numbers, you are going to put right there. When you look at your percentage of carbon dioxide experimental, which was this right here, you are going to take 100 and you're going to subtract that number and you're going to put your experimental copper right there. Okay? So, once you get that number, all you have to do is write me a sentence or two saying which one of these copper carbonates you think you analyzed. You should really match up this number. Whichever one of these it matches better would be the one that you analyzed. So make your best guess. Write it up. Take pictures of these 3 pages. 1, 2, and 3 with all of the information that I told you to calculate on the board right there. Okay? And submit those to me. And you can submit it in Canvas or via email, whichever way you want to submit that to me. Get that light out of your way. And that's what you got to do for your 25-point lab assessment grade. Okay? Email me questions if you have any. Have a great February week off, and I will have videos posted for you when we return.